Hello students, Professor Nugent here. In the last video we discussed how to include qualitative information in our regressions. We saw that by including a binary variable which is equal to 1 if the attribute applies to the observation and 0 otherwise, we can look at how the dependent variable varies for the two different groups or observations which have some observations which have the attribute and others that don't. In this video, we're going to focus on including qualitative information on multiple attributes in our regressions. And the way that we can do this is to include dummies and or interactions amongst dummies for the various groups, except for one. We leave one out because of the multicollinearity that would result if we include a dummy variable for all of the groups or for all of the attributes. And the one dummy that we leave out serves as the base group. So the effects that we get are for the group of interest with respect to the base group. There are two ways to implement this. The first way would be to create a dummy for each combination of attributes. So you're creating a new variable that is a dummy variable that is equal to 1 for each unique combination of attributes. The other way to do this is to use an interaction term. Now let's look at an example so that we can see how we would implement each of these methods. Say we want to look at earnings as a function of sex and marital status. We would have two dummy variables. Female equal to 1 if female, and 0 otherwise. And for the purpose of this example, we're going to take the very narrow-minded approach that we're thinking about sex assigned at birth, and we're going to, so to speak, clean the data so that we are only looking at female and male sex assigned at birth. We're also looking at married, which is equal to 1 if married, and 0 otherwise, where we say that otherwise includes everybody who is single from all the ways that you could be single. We're keeping our example simple. So if we think about method 1, you have 4 different groups. We're going to look at 3 dummy variables, and then one of the groups is going to serve as the base group. We can generate a variable FEMMAR, which is equal to 1 if female and married, and equal to 0 otherwise. we can generate a dummy variable that is FEMSIN equal to 1 if female and single, 0 otherwise. This is for all the single ladies. Alright. We can generate a dummy variable male MALE MAR, which is equal to 1 if male and married, and finally we have our base group the base group is defined as male and single. So we do not define a dummy variable for male and single. We could run a regression. Let's look at a hypothetical population regression function where wage is equal to beta naught plus delta 1 FEMMAR plus delta 2 FEMSIN plus delta 3 and then we might bring in some variables that are not dummy variables, that are measured on a continuous spectrum, perhaps are measured on a different kind of way. What we're going to think about is bringing in level of education, so plus beta 1 times education plus beta 2 times experience plus beta 3 times tenure plus u. Alright, so this is the population regression function that we're considering, hypothetical. And what delta 1 represents is the difference in earnings between the female married group, the average difference in earnings between female married and male single. Right, because male single is the base group. Delta 2 represents the average difference in earnings between female single and male single, all else equal. And what are we saying all else equal? The all else equal stuff is all of this stuff. The education, the experience, the tenure, and the other stuff that's important for wage, but unrelated to our included variables. So this is our first method. We can implement this method using we can implement the same regression, get the same results using method 2. Which is to use an interaction term. The regression function would look like wage equals beta naught plus delta naught female plus delta 1 married. Now we're going to include an interaction term plus delta 3 female times married plus the other stuff. And this method will give us the same results if female is equal to 1 but married is equal to 0, then we just have delta naught. If female is equal to 1 and married is equal to 1, then we have delta naught plus delta 3. And delta naught plus delta 3 is going to be equal to delta 1 in this regression. If we're looking at male and married, then female is equal to 0, but married is equal to 1. So delta 1 represents the difference between male and married and male and single. Delta 3 then gives us the difference for females who are married. Alright, so this gives us the same result. We get the same difference in average earnings for the three groups relative to the base group, which is male single. Stay tuned to the next video. We will discuss how to bring in ordinal information into a regression, again using multiple dummy variables.